All right. Cool. Seems like we got, yeah, people from all over. Yeah, and thanks so much for putting that in the chat. And as you guys do that, I want to introduce our panelists real quick. So first, this is Veronica Ellingson. She currently teaches AP Physics 1 in Hudson, Wisconsin, but she has taught all the AP classes and been an AP reader, an AP writer, and a huge AP expert. So yeah, then we have Barb Austin. She teaches in Ohio, and has taught AP 1 and AP 2, and I believe is currently teaching both of those classes, and she absolutely crushed it on her scores last year. And then we also have Matt Stanich. He teaches at West Ranch High School in Southern California, and he's taught AP 1 and APC and been an AP reader as well. So yeah, we'll go ahead and get started. And my first question, oh yeah, if you have questions anytime, please go ahead and put them in the chat. We're gonna start with some questions that I took from people's responses in when people were signing up for this. Then we'll have some time for any follow-up questions. And then I know these amazing teachers through Positive Physics. I'll do completely optional, but if you want to stick around for a quick tour of Positive Physics, happy to do that. I can also give you an activation code that will give you a free couple months of Positive Physics. And yeah, so with that being said, we're going to go ahead and get started. And my first question, and we'll start with Veronica, is how do you handle pacing in your class? So making sure you all cover all the topics and have time to review.
I will first say what I did last year. So last year I did kind of what I usually do. And out of the what do we got now? 8 units. I break the first unit, kinematics, into 2 units. Um, to help with graphing, to help with science knowledge and math and all kinds of stuff. So to kind of get caught up with all kinds of things I feel like they need to be ready for AP Physics, I've broken up the first unit into two, linear motion and projectile motion. And last year I did not break up forces. I kept almost everything the same. So I did unit 2, unit 3, 4, 5. I went in order, but I threw circular motion and gravity in, oh shoot, before rotational motion. This year, I'm going to try, again, this is my second day of school. I'm going to try to do unit 1 as 1 unit, and then I'm going to break unit 2 into 2 units. I'm going to do forces, free body diagrams, Newton's laws as 1 unit, and then I'm going to do the circular motion and gravity separately. And then I'm going to try to do 3, 4, 5, 6, 7, 8. So usually around 3 weeks a piece. We did do an in-service on AI. AI will do a really nice job for you if you tell it, like I gave it the CD, I gave it the units. I said, give me a calendar for this many weeks and this many weeks of review, and it does a really nice job. So there's a lot of tools out there for teachers as well. So that's my plan. I'm going to try not to break up unit 1, but I am going to break up unit 2 because it's really, really big.
Gotcha. And real quick, how long do you try to leave for like review before the test at the end?
Last year I had 3.5 weeks, and that seemed to be a little bit too much. This year I'm planning on two solid weeks
Gotcha. And when
before the week of AP exams.
gotcha. And then when you say you're breaking up a unit, does that mean like you're gonna do if you're breaking up unit 2 into two parts, like you're going to do an assessment halfway through the
Yes, so
unit?
that's what
Okay.
I mean. Like I'll do it as like different quizzes, different assessments. Yeah. So I think I'll put friction in with the first part, but I mean, because circular motion, gravitation is not too much of the curriculum, but it can be an FRQ as we've seen in the past. Same thing with circular motion. So I mean, it's not to be missed or gone over too quickly. So yes, I would do those as separate exams.
Got it. Great. And yeah, Barb, do you do something similar to that?
No. So last year, I completely changed how I schedule AP Physics and how I use my resources. And so, you know how there's a suggested range for like covering a unit from AP Classroom? What I did was I used the minimum range so that for each unit, we did it sequentially so that I'm going to finish going through all of the topics the second week in January. So in order to do that, there are a couple of things. The only AP material or AP classroom material we touched was the AP daily videos. And then we did just a couple of multiple choice questions sets just so kids would know whether or not they wanted to sign up for the test. I was really, really rigid about not missing my deadlines. And so if we missed covering a topic, then we would do it the second go around. So I covered every single unit again from middle of January up until the last week in April. So first semester, we did like all of the problems on positive physics, except for usually the last problem set and multiple choice. And that was all I tested on. So I gave 3 summative tests, one first semester and one first quarter and 2 second quarter. And that was it. I did not have unit tests, but we did have almost weekly quizzes that were just like free body diagrams, like simple conceptual knowledge or simple factual knowledge. But they like knew their factual content, problem-based knowledge from positive physics. Then second, or the second go around, we did the more difficult problems on positive physics, multiple choice review. And every single week or every day of every single week, I gave my students like 5 multiple choice problems from AP Classroom. And then on Fridays, I would quiz them on 5 of those. So basically they had to know those. That would be like an 8-minute quiz. And then we would do an FRQ. So every single Friday, just about second semester, they were doing some multiple choice from AP Classroom and FRQs. And then I continued with the summative tests. And that was what we did. And so my pacing was, I set my schedule at the beginning of the year. And like I said, anything we did not cover in terms of concepts, the first half of the year, we covered when I did the repeat. And then between my final review and the AP test, we did a full length AP test. And then we also did more review on positive physics.
Gotcha. Perfect. Very interesting. All right. And Matt, what does your pacing look like?
All right. So typically I would try to like work backwards from the AP tests. First factor in like how much review time you want. I always seem to run over, so I'm trying to plan like to hopefully be finished with the material, like maybe like 2 weeks before that first week of AP testing, maybe 3, if I can swing it, because I think they moved the AP physics test up to the Wednesday of the first week this year. So it used to
Correct.
be the day of the second week. So it's
That was evil.
Yes.
Trying to get done like 2 to 3 weeks before AP testing starts. I used, as others said, use the kind of weighting from the course description from AP Classroom. You can see like how many days each unit should be taking approximately. I always find that the introductory units of kinematics and Newton's laws are going to take longer than what they recommend on the College Board website, just because it's going to
Matt, can I interrupt you really briefly?
Yeah.
You guys, I'm on my iPad and I have no idea how to see the chat. And I am not like a technical idiot. So I saw that someone just did a chat message to me. I don't know how to do it.
Yeah,
So-
I can just read it.
okay, so I'm
Actually,
sorry to interrupt you,
yeah,
Matt.
let me let Matt finish, and then
Okay, all right.
I'll send that question your way.
And I'll see if I can figure out how to see the
Okay,
chat.
all good.
Um, so yeah, I find kinematics and Newton's laws always take longer because it's the students like first taste of physics. Um, and they're going to be learning about how I expect work to be shown, and thinking in a different, more conceptual kind of way, answering questions in a more symbolic fashion, doing these derivations that don't have numbers in them and things like that. So those units always take a little bit longer. I generally try to get through kinematics, Newton's laws, circular motion and gravity, and maybe energy, or half of energy if I can, before the end of first semester. I start kind of in the middle of August. And then maybe second semester pick up with like conservation of energy. So cover like work energy theorem first, have that winter break, and then come back with conservation of energy. Um, and then I do them pretty much in order, the same way they're listed on the exam description, but I think I switch and do oscillations last. And I don't remember if I did oscillations and then fluids or fluids and then oscillations, but it made sense for me to put oscillations after rotation since it's like a variation of, it's non-uniform circular motion kind of essentially. Um, so think that is kind of how I'd approach it.
Gotcha. And Matt, I know we've like since AP1 is the most popular choice, we tend to focus on that. Just in terms of like the general strategy, is it similar for APC?
Physics C.
Yeah.
Physics C is always a tough one. We're a school that does mechanics first semester, E&M second semester, so we're doing them both in a year. And typically, all the students that take Physics C already took Physics One as a junior, so they're taking Physics C as a senior, and they've already had Physics One. So
Got
we
it.
can really blast through the mechanics pretty quickly,
Uh-huh.
just concentrating on the calculus and getting more in depth with the depth of questions and the types of situations that we look at. So I'm trying to finish mechanics by Thanksgiving this year, and then I'll have. Sorry that my lights are on automatic timer here. I'll get up when I'm done talking and wave my arms around, and they'll turn back on. So I try to finish. I'm going to try to finish mechanics by Thanksgiving. That'll leave me like 2.5 weeks of time to start E&M, and I'll get through like maybe electrostatics and maybe just introduce Gauss's law or something, and then hopefully that'll get me enough time second semester to cover E&M a little more comfortably. E&M's new to them, so it's going to take longer, and E&M is not quite as like in your face as mechanics. They've been throwing balls and seeing collisions and kind of living mechanics their whole life, and they know it from physics one. In E&M, we're talking about like electric fields, magnetic fields. There's, three-dimensional motion or cross products, more dealt with. There's, line and path integrals and surface area integrals. There's math they haven't seen before, even in Calc BC. And mentally, it's just a different beast for them. So I need to budget more time for that to get through everything well.
Got it. That's helpful. And somebody in the chat asked, I know Veronica answered it in the chat already, but just for some context, for Matt and Barb, how like what do your class periods look like? How long are your class periods and how often do you see your students?
I teach on a block schedule. So this year we have odd days and even days. Odd days would be like periods 1, 3, 5, even days 2, 4, 6. The periods are, I think, like 110 or maybe 115 minutes long.
Gotcha.
So that's good for labs and everything. And I see them every other day.
Got
Then,
it.
um, was that basically
Yeah.
the question?
Yep.
Okay.
That was it. And oh, and Barb put hers in the chat. 56 minutes every day. Got it. Cool. All right. Yeah. Next question I had is like what does a typical unit in your class look like? I know Barb, you kind of touched on this already,
Mhm.
that it changes, but what does a typical unit in your in your class look like? And how do you balance like teaching like the fundamental skills versus doing labs versus doing practice AP questions? And maybe we'll start back with Veronica. And Veronica, I think we lost your audio.
Right. You're right. Here I am. So today, I mean, today was the first, today and yesterday, AB block, I saw him for the first time, did a little syllabus. This is how you do well in my class. Here's all your resources. And then we started with a lab. I haven't even talked about linear motion, but it's comparing something going into constant velocity, something accelerating, how to collect data, how to look at trends. So it was awful. It's always awful. They don't have these skills. Like, I'm just saying they did a great job. But they have no idea how to write a lab procedure. Graphing. I mean, but we're starting day one. I know it's ugly. I want them to learn from their mistakes. So I'm going to work in more tests like problems as we go. So I always try to take previous lab questions and make them actual labs. This is not one of them, but just getting exposure of, what are you going to measure? Describe how you're going to measure. What is a procedure? So they had a stopwatch and a meter stick. I said, tell me what you're going to do with these items. It was a struggle, which I expect because I don't really have a lot of science background at my school. So, I'm constantly working that in. Not a plug for, again, we're not here to plug positive physics, but it's nice to work in those unit 0 stuff. So I have unit 0 stuff assigned along with unit 1 stuff, or like linear motion. And I made my own unit 1 with, I think, the traditional units 1, 2, and 3 that that is there. So yes. I try to work it in because I feel like it's kind of boring. I used to do this with regular physics. I used to do a unit 0 with regular physics. I'm like, this is boring. I'm trying to get kids to like physics. Let's do physics and then work in those skills. So I'm constantly working in those skills. I'm constantly modifying quizzes and exams and activities so they look more like the exam. So, I mean, it's good skills for good scientists. Just try to work those in as best you can. So I feel like I have a very active classroom. I don't do a lot of time lecturing. I feel like it's very minimal. So I pair it to how I teach mountain biking. I tell you the skills, I tell you the key points, I demonstrate it for you. You practice, I give you feedback, and then you hit the trail. That's kind of how we do physics. Like, it's all about the kids applying it. I do this in many different ways, but to make sure we're all on track, I think positive physics, again, I'm not here to promote it, but I think it's a great way to make sure they're getting those skills, getting those feedback, because I don't like homework, but I feel like an AP, I kind of have to assign it with where kids are coming from.
Gotcha. And Barb, I know you already touched on this a bit,
Sure.
but did you have, and a really interesting approach. Did you have anything like maybe extra you want to add about your approach?
Yeah, I'll say a little bit. So I'll do too much information, but I'm 62 years old and I decided 2 years ago to do something crazy, which is to take up figure skating, which I did as a child. And so I have a life outside of school, and I therefore decided my students are going to do more work than me. And so I offload. So for our first unit, I give them a procedure. It's very step by step, very structured on how they do every single skill. This is how you do a data table. This is how you do a graph and analyze it. This is how you linearize. This is how you do a lab write-up. I think I have like 6 or 7 different skills. They, in the very first section of their lab book, they have to write that procedure down. And then we do an example. So we have 2 different examples. One is the heating up water with the coffee cup heater that I do. That's their first set of data. And their second set of data is we do buggies. And after that, they either do it or they don't. And if they don't, they get a 0 if they do it poorly. So that was one thing, is that I told them, I have a life. This is where I'm doing it. You guys are AP students. This is supposed to be first semester of college. You need to take responsibility for your learning. They have homework every single night. We do, which is watching AP videos. And they usually have to do a text entry. We do, someone asked about labs. I'm a firm believer in labs. So every single unit, we do 1 to 2 labs. Every single unit has kind of like an orientation. I was thrown for a loop this year because my kinematics unit was supposed to be, so you want to design a video game. And I was going to have them show their knowledge by using Scratch to design a video game. Scratch is not on our approved vendor list. So we're not having a project, but I think that helped motivate students. And they knew that if they didn't like get their other knowledge done, then they would not be finished. We would move on and their AP score would suck. Also, the videos in positive physics, I used those a lot more this year. And again, that was homework. So it's not really a flipped classroom, but I just gave my students a lot more responsibility and it paid off. So.
Gotcha. Yeah, and Matt, what does your typical unit look like, and how do you balance like teaching these different things?
Yeah, so I try to start off with some kind of introductory activity, maybe like a quick little investigation they could do at lab stations, or watch a little video clip from YouTube that kind of highlights or demonstrates a certain situation that you want to like tease out some future, expectations, like what do you think might be happening here? Kind of get a feel for what their basic knowledge level might be. And then throughout the unit, we'll typically do notes. I give out kind of old school, like printed out sets of notes where we go along, they fill in blanks as we go over them in class. I use Notability on my iPad so I can annotate like the PDFs as we go. I post copies of them after we do them together. I have a bunch of example problems that are built into the notes where we'll go over some of the concepts together as a group. Then they'll have time to work individually on the examples. We'll get back together, they'll check them, or maybe I'll post the key for them to check at home. I try to do roughly two labs per unit if I can. Not every unit am I able to squeeze that in, but it's a good thing to shoot for. And at least one of those labs, I try to do experimental design style, where they have to like, at the beginning of the year, they're not going to know as much about all the equipment, how to set it up, use it. So at the beginning, I'll have them, I'll show them maybe how the lab is set up. They'll draw the picture of it. They'll maybe write a procedure, and then we'll collect data and kind of get into it slowly. Towards the end of the year, the experimental design labs are going to be more open, and I try to model them as much as I can off of like the experimental design FRQ. So they're going to have to generate a linearized equation, tell me what they graph horizontally, vertically, what the slope's going to represent. One good twist to put on that is in your lab group, if you have 3 or 4 students, after they've kind of learned about linearizing, have it a rule that every person in the lab group has to do a different linearization. So they're all going to use the same data, but they're all going to maybe graph different quantities, like vertically and horizontally. And then they should all get the same thing ultimately from the slope of the graph, but they're all doing it in slightly different ways. This is assuming, your equation is kind of complex enough to lend itself to that, but you can always find at least like 2 different ways of, linearizing something, if not more. I like to use the topic questions from AP Classroom. I think those are good, like quicker examples for the students to work on. I find the multiple choice progress checks on AP Classroom to often be a little more difficult than what the questions on the actual exam might be. I do FRQ reviews before the tests where I'll have them write out their answers to the FRQ on like a written page. I never have them submit their FRQs on AP Classroom. Grading those on AP Classroom would be like horrendous. So they do all their work written out on a page. And then at the beginning, we'll do scoring guidelines together. I have them score their work and correct it in color. So they're going to write their score for each part. I got a 1 out of 3 here, a 2 out of 4 there, a 3 out of 3 here. Anytime they miss a point, they have to write a correction for their work in color, and then they put their final score up at the top in color. And we can talk about like, an 8 out of 12, that may seem like a terrible grade for, an AP student that you're used to in other classes, but 8 out of 12 might not be that bad for a physics FRQ. So they score them and correct them. And after a while, they've learned how that process works. And then I can just like maybe publish the scoring guidelines, or they can use the scoring guidelines on AP Classroom, and then they'll turn in their self-scored and corrected work. Um, I think that's most of what I said. I use positive physics, of course, throughout. I kind of limit, I don't assign every skill from every unit. I find that would be a little overwhelming for the amount of time. So I pick and choose what questions to use. A lot of times within a skill, I'll eliminate certain questions just to make less questions from that skill. I use the physics classroom and do concept builders from there as well. And I have like a little warm-up activity right at the beginning each day so that I can take attendance and pass papers out and stuff while they're engaged with some little quick question or ranking task or something like that.
Gotcha. Perfect. Actually, that transitions really nicely to the next question. Also, I see Dana, you had a question in the chat. Let me put that after the next couple here, but I will ask the experts their thoughts on that.
Jack, I was gonna
Oh
add
yeah.
one more thing. I forgot a resource that I've used a lot in the past, but I've not used as much this year, but it will address some of the things that people asked about in terms of derivation and lab design. And that is AP Workbook has kind of an excellent structure starting with unit 1 in terms of leading students step by step on how to do a derivation, and also step by step on how to do experimental design. So the kinematics units AP workbook is very highly structured. And then as you go on through the workbook, it gets less and less structured. And so if you can kind of choose the ones from each unit to kind of follow along building that source, those can be extremely helpful.
Got it. And yeah, that also kind of starts to get into the question here. No, it's perfect. Perfect transition. Yeah, so what 3 resources do you use? And it doesn't have to be exactly 3, but just I know sometimes just getting a list of 10 resources can be overwhelming for new AP teachers. So if you were to focus on like just a few resources to use in your AP class, yeah, what would you use? Maybe we'll go back to Veronica.
One more thing, AP Workbook, especially Unit 1 does a really nice job of linearization too. So that's in there as well. So again, that's a great tool, modeled, gets kids to think how we want them to think for the AP exam. Again, I'm not paid to do this, but I cannot recommend positive physics enough. I use that for AP physics. I use it for regular physics. And I've used it for C in the past, and I've used it for 2 AP Classroom. There's some good stuff there. I feel like the topic videos are short and sweet. And then I will use those later for practice, for multiple choice in the exams. And I just put in there PhET. PhET's a great online tool for simulations. So if you don't have a lot of lab equipment, that's a great way to do a quick lab to see what's going on. What else I was going to say? Oh, flipping physics. I use that a lot. So I use a lot of those videos a lot. Just as supplemental things. I don't really use a textbook. Yes, I know we have to use a textbook, but I like using other resources. I do have them use a textbook just to take notes for a frame of reference. But I usually start with an inquiry lab, and then I have them dig in a little bit. Yeah. So
yeah,
yes. And next go round for curriculum, I do want Pivot, because I've worked with people who've worked at Pivot, and just like how I know they set things up sounds pretty wonderful. But for now, I'm using PhET.
Gotcha. Barb?
Okay, so I like positive physics. I will give a critique of it, Jack,
Sure.
sometime later. But I definitely use positive physics for building concept knowledge. I like AP Daily videos because they are kind of a nice wrap up for what I've done during the day, kind of just like does a good job summarizing. Um, I know this is going to be weird for a resource, but I really, really love the Pretty Good Physics listserv and website. It's so phenomenal for new teachers. I've gotten so many good ideas. That's where I get great lab ideas. And so I'm going to, especially like Dan Burns. Oh my gosh, he's such a great person. So that's going to be my three resources: PGP,
Got it.
Positive Physics, and AP Classroom.
Got it. And Matt?
Yeah. So in addition to positive physics, I mentioned the physics classroom where I use concept builders. That's pretty much the only part of physics classroom that I use, but I know they have like other spots in their site that students can use, assign work and stuff. I use these ranking tasks called TIPERS, TIPERS. That I'll have them do like one each day at the beginning of class just to get them thinking and engaged while I'm doing attendance and stuff. Those are tasks inspired by physics education research. And there's like an entire book of them. They cover everything, in physics one, physics two, physics C. They're good for all levels. You can just find ones that are easier or harder for your students. And they go pretty quickly, and they lead to some good discussions. AP Classroom, I like to use the topic questions and FRQ progress checks. As I said, I don't have the students submit ever their work for progress or for FRQs online.
Agree.
Just to grade them that way. And most of the time, I just have them do the topic questions on AP Classroom for practice, and I don't even transfer them into my gradebook because there's not a great way. You have to like look at them. There's too much clicking and just takes too much time. The AP Daily videos can be good. I mostly use those for students that are absent or want to get ahead, but occasionally I'll show portions of them in class, and we'll kind of talk about the examples together. Pretty Good Physics was mentioned. That is an excellent resource for physics teachers.
Everything.
Good stuff on there, as well as the other community forums, that are part of AP Central and whatever. But in particular, Pretty Good Physics is awesome. If you're not part of it, definitely look into getting on there.
Perfect. Cool. And then, yeah, I think, yeah, the last question I had is, what tips do you have for new teachers, and perhaps like what are some common pitfalls to avoid? I definitely might chip in on the second one of things that I messed up, but yeah, actually we'll mix it up and we'll go reverse order. And Matt, can I start with you on tips for new teachers?
Absolutely. So tips for new teachers, I would say network with other AP teachers. Pretty Good Physics, we already talked about that. Community forums on AP Central. Becoming an AP reader will help you gain a lot of insight into how the tests are scored. You'll get to meet other people there and have just wonderful discussions about all the intricacies of grading. You will really bring back a ton of good tips and tricks to use with your students as far as ways that they can not really game the system, but just make sure you don't lose easy points, on the AP test, and make sure that you're not saying too much or too little, being able to hit like that Goldilocks zone as far as showing your work or writing out an explanation for things. Try new things in your classroom. Don't be afraid to experiment, of course, pun intended. Turn FRQ questions into labs. That's always a great one, right? Like I found one a couple of years ago in a physics C test where they had like a meter stick that was suspended with a spring at a different angle. And I could set that up on the wall in my room. And then we could make predictions about, well, we hang this from the thing. What's the spring scale going to read? And if you change the angle, what happens with things. So turning FRQs into labs is really, really a good way of having them connect with that. Have students grade the samples of work that are available on the AP website for the FRQ questions. Have them grade it according to the scoring guideline, and then they get to compare it to the actual grades that were assigned to those same samples of work that year. Don't spend too much time on units and get behind. Always include material from prior units on your tests, so they're always like cumulative and building. I try to make my tests as much like the AP test as possible, so they're all timed with the same amount of time. 50% FRQs, 50% multiple choices. I score them exactly like a real AP test. And then I use rough AP cutoffs, right? So like a 5 on the AP test would be an A or an A plus. A 4 on an AP test would be a B plus, or an A minus. Embrace the chaos. Don't be afraid to make mistakes. Get to know your students. Build relationships. Have fun. That'll have them buy in. And if you can try to build like a legacy um, for your program, that will help them buy in as well. I've been doing this long enough now that I've had like, younger siblings, middle siblings, 3 or 4 from the same family that come through. So I've started making posters every year where at the end of the year, everyone signs the poster. Seniors can put like what college they're going to, what they're majoring in. And then next year when the students come in, it's like, oh, there's my older sister from 3 years ago. Ooh, this person went to, XYZ university. I want to go there. Like maybe I can get there too. Like it shows them, what's possible. And then they know that their name's going to be up there. And I find that, gets them to buy in and like work a little harder.
Got it. Love it. Yeah. Barb, what about you? What tips do you have for new teachers and common pitfalls to avoid?
Okay, so physics, I'm convinced, is the most challenging subject to teach and learn because of the formal abstract reasoning that is required. And some kids just literally don't have the brain development yet. And so the lore among physics teachers is that it takes about 7 to 10 years to become really skilled at your craft. So if you are a brand new teacher, just, recognize you're probably going to suck your first year and you're probably going to suck your second year, and just don't worry about it. You're just going to do your best. I agree with Matt. You don't want to get behind. Make sure that you like cover everything, because you will have a couple of kids who will be able to keep up with you, and you want to make sure that that you get to everything for them. But I think, find your community. That is so essential. For me, obviously it's PGP, but just give yourself grace. It's really hard to teach physics. So
That's great. Veronica, what about you?
I totally agree. I had no idea what I was doing when I first did this. There's no way you would say like, "Oh, you're going to be writing the exam someday." Okay. I would never have believed you 20 years ago or 25 years ago when I taught math for 3 and then I did start doing physics 25 years ago. Never would have believed you. But everything that everybody said is great so far. I really like what Barb has said, not just give you grace, but what she said earlier. Remember to try to get the kids to work harder than you are. Kind of hard as a new teacher. When you assign problems, I know it's hard to do this, but it's really important to do the problems ahead of time. So make sure you do the problems. If you're assigning the problems, I always do the problems. I always post the answers for AP. Again, there's 40 questions or 40 points in the FRQ. Only 2 of them are correct answer points. So it's all about the process. So again, I show my process. I let them see my work because they need to know how to do it. So if they copy, it's not going to do them any good. But yeah, I think it's good to do some problems. I know it takes time, but doing some of those real FRQs, doing multiple choice, or just doing all the positive, physics problems, just make sure you are feeling confident with those. But as I say, the last couple times, don't forget to have fun. So if you're not having fun, the kids aren't having fun. So make sure you have fun. So yes, you're doing some hard stuff. You're making kids think like they've never thought before, but make sure you're having fun. And I can assure you the kids will have fun too.
I want to add something. I want to second what Matt said. You will go insane if you try to grade the FRQs of students. I will sometimes have them switch. I mean, you always want to give them the scoring guide, but I don't start scoring FRQs until probably April, and I only do it for the students who ask me to do it for them. So,
Yeah, well, to add to that, I will grade their FRQs, but only on tests. anything that we do is like practice FRQs. We
Yeah.
either grade it together as a group where I go over the scoring guideline with them, especially
Mhm.
earlier in the year where they don't know how to read a scoring guideline, or they'll do it for homework or something and turn it in. And then I just quickly look through it. And that's why I have them scored and corrected in color. I see their work in pencil. I see their scores in color. I see their corrections. And then if a kid's getting, 60s on every test and magically he's turning in FRQ assignments that are all perfect 12 out of 12s, he's just copying from the guideline, right? And the other thing is to piggyback off of what Veronica was saying about having fun and stuff. I will keep a book, actually a book that some former students gave me of terrible bad dad jokes. It's like 400 of them in this book. So I just have it there. And if I see like people getting bored or something, I'll just take a break and have someone call out a number from 1 to 400 and we'll go through a couple bad jokes. And that's their punishment for, falling asleep or something.
That's fantastic. Yeah,
Oh, Jack, I am such a loser. I'm going to add one more thing. The dad jokes reminded me. So every single week we do a mantra for things that kids do wrong that drive me crazy. So we do this at the beginning of class. We stand up, we raise our arms, and then as we're slowly lowering them, it'll be the phrase for the week. So like mass is not weight, numbers need units. Stuff like that. So and we say that every single week. So like one of them is G is not weight, mass is not weight, weight is M times G. So if you think about like the mistakes students consistently make, that will be a mantra. And my students absolutely love it. So, and we'll do like the same phrase all week long.
gotcha. Yeah, if I can just add a couple things, like one, I know Matt was talking about having the students grade their own. Like, not only is that a huge time saver, but also having them, like, giving them an understanding of like how they get points is super crucial. Also, I think Veronica said this earlier, and she mentioned this specifically when we did this another time before. I know she doesn't love to give homework, but she's like, with AP, I kind of have to. And I loved it kind of changed my mindset when she said one thing she does is like making sure students practice like fundamental stuff, like things they can be really successful on at home. I know sometimes she does science positive physics at home, and so that like because your class time, and I know I felt bad for there's somebody in the chat who was talking about how they start really really late and they have really short classes, and yeah, your class time is so valuable. If there's anything like if they can learn kind of those fundamental skills outside of class, I found that that's super helpful. Um, yeah, so let me go ahead and then go on to questions from the audience. There were a few um I didn't catch before. Oh, let's see. Oh yeah. Mr. Jimenez said like how many grades are you putting in the grade book? Like how do you balance that? I know like it's time consuming but also like important. How do you guys balance putting grades in the grade book? Yeah, anybody.
Okay, I'll just jump in. So I try to make putting grades in the grade book as simple as I can. So I'm really thankful that Positive Physics links up with Canvas, and then Canvas will automatically export to like we use Infinite Campus here. But that's all automatic now, so I don't have to transfer grades from Positive Physics. I do still have to transfer grades from Physics Classroom, but I just do those unit by unit, not like concept builder by concept builder. So I'll do all the projectile motion concept builders at once, or all the 1D, stuff, or all the Newton's laws, and I just transfer it as one big grade. I'm trying to cut down on the amount of grading that I'm doing. So I'll put in like FRQ reviews, a lot of the multiple choice reviews I don't necessarily put into the grade book. I'll put in notes in there, labs that we do. And this year, I'm trying a new thing where any of the written work that we turn in, labs that they've done by hand, the notes which we take by hand, maybe printed out problem sets, which we occasionally do, or FRQs. Any work that they turn in by hand, I'm not taking it if it's incomplete. I'll give it back to them, they can complete it, and then I'll take it after it's complete. And hopefully that'll let a few less people kind of slip through those cracks. But yeah, lots of grading. I end up with a lot of assignments in the grade book by the end of the year because there's probably, at least 5 or 6 things per unit plus quizzes and tests that I'm putting in there.
I'd say over time, I've done less and less grading. I do a ton of activities in class. I don't grade a single one of them. I do grade positive physics, and just like Matt said, I do it per unit. So I'm not putting in a ton of grades. I do 3 quizzes per unit. So if I do, like I said earlier, I'll have 9 units. I have an exam for each, 3 quizzes for each, 3 10-point quizzes, 50-point exam. Lowest quiz drops, exam score replaces quiz score. So I really encourage learning from their mistakes. And yeah, the less is better.
Gotcha. I'm realizing a lot of those questions, panelists, you guys are amazing. You're answering those questions in the chat as you go. Yeah, so let me open it up. If anybody has any questions, if feel free to put it in the chat or unmute yourself. Yeah, let's take a little bit of time for questions. After this, I'm gonna do a quick demo, completely optional to stick around, of positive physics if you're not familiar with it and wanna see what that looks like. But yeah, any questions in the chat, and or feel free to be brave and unmute yourself and ask.
While we're waiting for anyone, I'll just add that I'd use positive physics for like kind of quizzes as well. I'll do like one or two per, maybe two or three per unit, depending on how big the unit is. And the way that I work my positive physics quizzes is um, I don't scale them at all. Whatever score they get is their score, unlike a test where I would scale it. And for the positive physics quizzes, I like to give them our retakes. I'll do like a couple retakes. They can come in, sign up ahead of time at lunch, and I'll give them full credit on their retakes. It's mostly I just use for like the basic knowledge, not complex, you know, challenge questions where they're having to work out hard problems. Just the very basic stuff for those positive physics quizzes. And if they don't get it, it's a little lower stakes. They can retake it for full credit.
Perfect.
I want to give my critique of positive physics because I think that people who have not used it before, especially if you are a new teacher, there's like only one major problem with it. And that is that I don't know how many of you are actual physics majors. I'm an actual physics major, not an education major. And my professors, and I went to a very highly prestigious physics program. My teachers always began every single thing by writing out the equation and then solving. And they were really good examples of how a scientist solves problems. And so in positive physics, because there's no written work, you can just like, numbers on your calculator. And so I actually made forms that at the beginning of the year, students have to hand the form into me and it has to be complete in order to get any points whatsoever. And I also have, I can't remember what they're called, but they are little, they're like heavy duty page protectors. It actually has a name and you can purchase them. And so it's like a mini dry erase board. I have like the problem solving paradigm you should use with kinematics. So, listing all the variables, the equations, and my students, because I really want them to write things out because that's an essential skill for AP Physics. It's like a thorough derivation. And so that's like the one kind of caveat with using positive physics is that you have to have another vehicle for forcing them to read with a pencil, think with a pencil. Those are some of my mantras. So anyway, that's just some things I would say.
Gotcha. Barbara, I was a little scared what you were going to say, but if you actually brand new, so that there's a perfect transition. We do have a much better way to print problems now. So if you go under from the start, positive physics was designed for, especially on the ones like once you get down to complete problems, to challenge problems and things like that. When I was first using it in my classroom, when it was only a classroom website for my students, kind of from the start, I would screenshot the complete problems, make them fill in their numbers, make them write out their work and turn it in. I don't consider that a critique. That's just a definitely like a good advice to if you are using positive physics or any other like online resource, getting them to show their work and turn that in somehow is super critical. Obviously, like on the AP test, there's very few points for the right answers. It's so much of it is for the process.
as I tell my students, I have them write their, I have a binder check, they have their notes, they have their check questions, but one of that's PP work, that's their positive physics work, and there's certain problems you cannot do without showing work. I mean, there's no way you can't put pencil to paper to do a lot of those problems.
Right. Right. Awesome. I think that might be it. Again, if you want to stick around, I'm gonna do a quick demo for people who haven't seen positive physics before. But I just wanted to give the biggest thank to everybody who came out today, and then thank you so much to Matt, Veronica, and Barb. It's so helpful for me, and I know for everyone else to learn from you guys. And yeah, I'll shoot everyone a recording of this. And again, thank you so much for coming out. If you want to stick around to see what positive physics is, I'm happy to show you around. But yeah, thanks Matt, thanks Veronica, thanks Barb. Really appreciate you guys.
You're welcome. And
Right.
for audience people out there, if you have any follow-up questions or want any more details about something that I said or mentioned in the chat, you can see my school on your screen, West Ranch High School. You can find my email on there, and feel free to email me and just say that you're from the positive physics Zoom, and I'll be happy to help you out however I can, as long as I'm not like super overwhelmed. But there you go.
Awesome. Thanks, Matt.
I just have random strangers email me, so you can, I don't care. You don't have to identify yourself. And I'm being totally serious. Random strangers just email me. So I put my email a couple of different places, and Jack, I don't care if you share it with people. So
Yeah,
Yeah, I'll throw mine in the chat as well.
okay.
perfect.
Hey.
Awesome. All right. Well, again,
Hey.
thanks so much. Yeah, I'll shift over to showing around positive physics. But yeah, if I know we've ran far over, I think what I said on the schedule. So yeah, please hop off if you want to do something
Bye,
else. You're
everyone.
already an expert on positive physics. And yeah, thanks again,
I
Barb, Matt, and Veronica. All right. Yeah, so real quick, if you do want to stick around, let me bring up positive physics here and I'll show you around. Also, we have a code START25. We'll give you free access to the site for the next month or so. And then after that, like it does require a subscription just because we have to like charge to stay afloat. But we do have a pay what you can option for any teacher paying out of their own pocket if their school doesn't cover it. Yeah, so let me log in here and I'll show you just a super quick tour of what positive physics looks like. So it's a huge bank of lessons and questions, and I logged into a teacher account, and I'll also show you what students see. By the way, we have positivephysics.org, positivechemistry.org, and positivestem.org. They're all just different doors to the same place. Oh yeah, Ben and Abby, do you mind keeping an eye on the chat while I do this one? This is where I get overwhelmed. Okay, cool. Yeah, just real quick. Bennett asked, I think, unless it disappeared. Oh, how much is a subscription? Yeah, so the pricing is actually before I show you the pricing again, let me reiterate, we want this to help you. If your school won't pay for it, then you can just shoot me an email. We have pay what you can pricing for teachers paying out of their own pocket. I taught at a Title I school where I had to buy my own paper and copies at one point. So like we want this to help you. If your school is paying, you can click on the grab a quote right here. If you have 3 or more classes, it's $400 for the year. That price goes down if you have only 1 or 2 classes. And that price also goes down per teacher if it's for more than one teacher at your school. But that was just from the home page. I clicked on grab a quote. But again, if you ask your school and they say no, but you still want to use it, shoot me an email. My email address is all over the place on the site. Always happy to answer your questions. Happy to send you the pay what you can option. Yeah, so let me show you. I'm showing you a student account right now and what a typical lesson looks like. So this is what students see. You see something very similar, but you have some extra buttons. They can see when you assign something and see whether it's linked to Google Classroom or Canvas or Schoology. Like the panelists said, we really focus on fundamental skills. And yeah, if you have questions anytime, put those in the chat and Abby will interrupt me and put them in there. Yeah, so this skill starts with a video and key points. this is just making sure your students understand what, like how to analyze a free body diagram, what net force means. Anything that's in blue is a randomized value. And as students practice, right answers turn green. And if they get something wrong, a little red X appears. And it pauses for a little bit, so they have to think about it before they try again. We built an AI tutor into the site. It won't give them the answers, but it'll help guide them. Kind of the goal here is to make it so it feels very doable and they're not tempted to just, screenshot it into ChatGPT and have it spit out the answer to them. Yeah, as you go down the dashboard, it gets more challenging. Down to these complete problems, which are where they're putting those skills together. I can't remember if I mentioned this, but anything you see in blue is a randomized value. So every student's getting different numbers in their questions, and so their answers will be different. And then when you get down to these later sections that say like challenge, these are more like AP level questions. But we also I think what we do really well is make sure we have those fundamental skills, and these are things that students can really complete like at home by watching the video. New this year, we also have, so all of our questions are multiple choice or numerical, besides these new free response questions. This is our new toy that we've been excited to play with. And so um these ones are, Abby is also, she'll show you in a little bit. She made a copy of one of the released FRQs from the exam. We still have to check with College Board to see if we're allowed to share. We were going to make that part completely free, but we just have to make sure that we don't violate anything from them. So this question is like, are these initial average and final velocities possible? If I say no, and let me give a wrong answer, the initial velocity should be greatest, then it checks it and they can say like, oh, I got my answer right, but my explanation is wrong. And then students can fix it. And so I should say the average velocity should be between the others. And it liked that. So it's a great way to get your students practice writing. Yeah, so I use this for this work mode for classwork. There's also an extra practice mode where students can have more practice, and then also an assessment mode. The assessment mode pulls questions directly from the homework, and it's completely randomized. So as a teacher, I can say, I want 2 questions from this constant velocity, 4 from the average velocity rule, 4 from the embedded math, etc., and it forms that into one assessment. Another new thing this year is when students take assessments, it forces them to work in full screen mode, and then the AI tutor goes away when they're taking the assessment. If they get something wrong, they can't fix it right away until they're done with the exam. Then they can finalize. The AI tutor comes back, and they can start answering things they didn't answer before. Oops. And they'll get a separate correction score that increases as they make corrections. Yeah, actually, let me pause right there. I think I may have missed some things in the chat, and then I'll also show you kind of how to that's kind of what the student experience is like using positive physics. I'll show you the teacher side of it in just a second, but let me check on the chat and see if I missed anything.
Before you go to the chat, can I ask something?
Sure, yeah, please.
This is Kenya. I love it. So the idea is that when you use that for a test, you create the test, everything is forced to be full screen. Still, I have to deal with the thing in the school, so they have to have some sort of browser blocker, etc. If I'm using that in a test, right?
So there's such a thing as a lockdown browser, but those are super expensive. So this was kind of like our cheaper alternative to that. So they can just be using Chrome, and it just forces them to take it in full screen mode. What's different about ours from a lockdown browser is if they, let me go to a different, oh, I didn't, yeah, oh wait, I already started this one, my bad. So a lockdown browser can just completely lock a student in to something. With ours, like Google Chrome doesn't allow you to do that, but what happens with ours is if the student leaves, it'll tell them that they've left and that they've caused a violation. And then as a teacher, when you go into your student scores, you can see, I did it on Unit 2. You can see that this student, they exited the full screen. I think you're talking, but you're muted.
Sorry, I forgot. So you have the timestamp. So that's awesome. So you have the timestamp, so you know when that happened.
Exactly.
But do you know in which point of the test they were?
You don't, unfortunately, at this point.
Yeah.
Yeah. And so
Okay.
generally what I tell students is like or what I would tell students is like if you exited full screen, you need to tell me immediately and kind of like sometimes like if their battery on their computer starts to die, it'll like
Uh-huh.
pop up a message or something and that will cause them to get a violation. So I just say if if you're taking the testing class and you get a violation, raise your hand, let me come make sure that like you haven't switched tabs, you're not going anywhere else. Then you can refresh the page, get back in full screen, and I'll still give you credit. As opposed to if you have a violation and you didn't explain it to me, then I'm going to make you redo the test.
Okay, so that would be my next question. If you see like one or two violations, but they didn't raise their hands or anything, so you have them to retake or take another test or
Exactly. Yeah, and when you hit
okay, so that's part of the rules. I like it. Okay.
yeah,
Thank you.
if you hit reset right here, our assessments are so randomized that when they retake the test, it'll be a completely different test with everything like it'll be different problems, it'll be different numbers, it'll be a completely new randomized test.
Thank you. That
Sure.
is lovely.
Great. Okay, cool. Yeah, let me show you the teacher side.
About, we have a couple questions, Jack.
Oh, yeah.
What about using positive physics for AP only or for using it for honors, IB, regular classes as well?
Yeah, so it really can be used for any level. The way I really differentiate is with I keep getting I'm on my student account. I keep getting violations. Um so yeah, it can be used for any level of physics. I taught in a school in Memphis, a Title I school that had students on a very wide range of levels. If you're using it for a standard physics class or a conceptual physics class, then just going like it just matters how far down the dashboard you go. If you're using it for AP, you want to make sure you get through these initial skills. Like they should be able to do those pretty quickly. They should maybe at home, maybe by themselves, and then they should go all the way to the end of the unit. If you're using it for a lower level class, then like a standard level class should be able to get through like the complete problems, the lab problem, maybe the graph concepts, but these ones that I'll show you how to set this up where these last ones default to bonus. But yeah, it really can be used for all levels. If you're using it for AP, it works great. Veronica helps write the test, and she's like, as you can tell, like, and I swear I don't pay her, but she's one of our biggest fans. But using positive physics alone isn't sufficient to prepare students for the AP test. You still need to use AP Classroom. You still need to do labs. It works really, really well to teach students the fundamental skills. We're also adding those free response questions, but make sure you're still using labs. Make sure you're doing like practice AP problems on top of just positive physics if you're using it at the AP level. Yeah, were there any, Abby, did I miss any other questions before I share the teacher side?
Just about how to like set your class level, which I guess you'll show on the teacher's side.
Perfect. Yeah. So when you go to first thing is for the teacher side of things, we put together this help/FAQs page that takes you through like all the directions here. If you forget anything I say, you can check those out. But yeah, to set up your class, the first thing you do is go to sections and settings and section setup. It's a lot of S's, and you just set your classes to active. If you put basic, here, let me show you I put basic, standard, advanced. I'll just make this inactive. The only thing that does is when you go back to your dashboard, you'll notice that for basic and standard, by default, we make some of the sections bonus. So if you're teaching an AP or honors class, set it to advanced, and then almost all the skills will be required. We made this free response ones bonus because like AI is not always right, and so we wanted students to do it, but we didn't want to make it part of their grade until we do some more testing. That's why it says beta right there. So yeah, that's how you differentiate between your class periods, between your levels. And then if I go back to the settings, if you're setting up your class, just also take a look at some of these other things, like what you want to use for gravity. I highly recommend 10, just so students spend less time punching numbers into a calculator. AP test accepts 10. And then on the far right side, if you teach a very lower level class, you can turn on this yes to show manipulated equations. And what that does, let me duplicate this tab, is that when I go into the questions, I taught a lot of students who were really, really low in math. And if you turn on the reference sheet that we have, it gives them every equation pre-manipulated, and it really lets students who struggle with math focus on the physics. Don't turn that on for your AP students. They need to be able to do the math, but if you have really low level students who struggle with math, already don't enjoy their math class, you can really like allow them to focus on the physics by turning that on. Yeah, you can decide whether you want the AI tutor to be on. Here, set how long you want that pause to be. So like we usually recommend 3 or 5 seconds. If you want your students to hate you, you can set it to 20 seconds. And just some other things that like late work policies and stuff you can set up on the settings. Once you've done that, when you go to your dashboard, you'll see that there's a column for each class period that you teach. And then to get your students on board, there's kind of 2 different ways to do it. The first way is if you don't use Google Classroom, Canvas, or Schoology, or your IT people don't answer your questions, you can have your students sign up by going to positivephysics.org, clicking on Create Account, clicking on Student. When you create your account, you'll create something called a Classroom ID. It's the same for all your class periods. Then you'll give that to your students. They can sign up, and they'll select which class period that they're in. And that's how they get their accounts connected to yours. If you're lucky enough to use Google Classroom, Canvas, or Schoology, make sure you look at the directions on here, because your admin has to, you can pull in your students, but your admin has to like go through a couple steps just to say that we're a trusted site. And if you do that, you can go to Manage Rosters, and you can import your students. You basically map your sections to ours. Click Continue. It's the same exact thing for Schoology and Canvas. And you can pull all your students in. Then they have accounts. And then instead of having to create account, if they have Google addresses, they can just click Login with Google. If they don't have Google addresses, they can click Request Manual Login Credentials, and we'll email them a username, password, and a classroom ID. And then they'll be in. Yeah, let me pause. And Abby, did I miss anything in the chat?
No more questions in the chat.
Perfect. And then yeah, the last thing is just creating assignments. So if you don't use one of these systems, you can just click on these green buttons and you can set a due date. That's the easiest way to indicate to your students what you want them to do. And it'll show up there. If you want to assign a bunch of things at once, you can click on this bulk edit and you can select everything you want to assign. Or if you do use the LMS, you can click on this, decide if you want to assign the whole unit or if you want to assign a few skills at a time. All right, so on that one. Yeah, I'll put a due date on it. And this will go into your LMS. It'll create the assignment there. And then it'll also, sometimes it takes just a second. It'll also create it on our side. You'll see the little logo of your LMS right there. And then when a student goes into practice, if I still have the student tab open, I probably closed it. When the student goes in to do their work on this one, they'll have a little submit button that'll allow them to, like Matt was talking about, he uses Canvas. So they'll click on submit. It'll send their grade over to Canvas or Google Classroom or whatever it is, and then that grade will be there. You don't have to worry about like the swapping grades back and forth. And then very last thing is if you want to, oh yeah, it's really customizable. Matt was also talking about how he'll remove skills or remove problems. So you can always click on these and say you want to remove, I don't want my students to do this lesson. Or you can say, if you go into a problem set and there's a specific problem you don't like, you can click on remove problem and you can remove the problem, or even just say, oh, I want them to do it on the homework, but I don't want this problem to be on the assessment, like that. So totally customizable. You can do whatever you want. If you get super into it, there's even an advanced feature where you can create your own course, where you can rearrange our course and then even create your own questions, including those AP style question, like even those free response questions. You can create your own, just giving it a rubric and an exemplar basically. But this shows you like how to do all those things. But that's if you get super into it. Yeah, I know that was a lot. We're over an hour into this, but yeah, let me stop there and see if anybody has any happy to stay on and answer any questions anybody has. Yeah,
When yeah, when we create like assignments or whatever, are they printable? Can I export them as PDFs if that's an option?
yeah,
I mean, I would prefer the students to use here, but given the opportunity to use them as PDF and stuff like that.
yeah. So if you go under the, it's definitely like I like to print anyways and still have them like enter their answers on the computer. If you go
Mhm.
under teacher and go to
Oh, okay.
this print part, you can select questions that you want to print. So what I like to do is I like to print out for this first one, I need to rename these so it's a bit more clear. But basically you can print out problems that have the numbers from your account, and I like to do those as a class. So it's like, okay, I'm going to print out problems with numbers in them, and then we're going to do those as a class. You can
Mhm.
also click on template here. Again, I'm going to rename it and let me do select all questions. Actually, no, I don't want to do that. I'm going to remove all the questions, and I should go to a different unit.
There.
Remove, and then I'm just going to go down and select all these guys. So I like my students to show work on the complete problems. And so what this will do is it'll create a PDF for you that has a blank anywhere that there's a randomized value. So what I would make my students do is they'd have their computer in front of them, they'd be writing down their numbers in these blank, they'd be showing their work on this, and then they would I'd give them a score for whatever they got on the computer, but I'd also give them a score for showing their work and turning it in. Because, like Barb said, that's so important, especially
Yeah.
for AP.
Think with a pencil. Yeah.
Exactly. Exactly. Yeah, great questions.
I did get a couple more questions.
Oh, perfect.
One was about if you teach physics and chemistry, can you have access for both subjects?
Yeah, every account comes with full access to all the courses that we have. So biology, chemistry, engineering, environmental science, physics, and physical science. If I forgot to, I'll put this in the email as well. But if you're like, oh, this looks interesting, I want to try it out, I'm going to give you an activation code. It's START25, but I'll email that to you as well, where you can get like full access to this um, for the rest of August as well as all of September, and then you can decide like if it's something you want to purchase. Again, if your school won't pay for it, just shoot me an email and you can just do the pay what you can option. Just make a small donation and we'll let you use it for that for the year. Were there more questions, Abby?
Yeah, we had one more asking about how our like challenge questions align with the AP exam. Like, are they on level with the AP exam? Are they easier? Are they harder?
Yeah, great question. So the challenge questions are designed to be on the same level as the AP exam, but they're much more numerical. So just make sure your students know that like these questions are hard, but this is not like we have these multiple choice challenge questions that are like they're practice AP questions. So those are a lot like the like what they'll see on on the exam. Then we have these challenge questions that are just hard numerical questions. They're like they take the same level of thinking as the exam. They're just not they're not the same style. And then these free response questions, these are only on the first couple of units. That's what Abby is working on now. So those will be more similar to kind of like the writing that's required for the AP exam. But again, in addition to positive physics, do labs for AP for sure. Also do like use the release materials from AP. All right. Was there more in the chat, Abby?
That's everything for now.
Okay. Cool. All right. Yeah, well, I will go ahead and close this down and send you guys the recording. But thanks so much for sticking around for so much of your Wednesday night. And yeah, I'll shoot you an email with a recording of this with all the information you need. Again, if you have any questions at any time, don't hesitate to reach out and ask. Yeah, Abby and I are always super happy to help you. All right. Have a good night. Good luck with the start of your school year.